All right. So the theme for Unit 4.1 is rational functions. So I have a couple screenshots here I want you to kind of think about as we're moving through this. We've got a little funny statement here at the top. You can see, holy shift, look at the asymptote on the mother function. I saw that on a website. I thought that was pretty funny. But what we're looking at here when we look at asymptotes is this thing of restriction, and restriction comes in the form of, when we look at domain, we talk about, well, what would work for our domain and what wouldn't work for our domain. And so rational functions have this special line, this special value, where basically the function becomes undefined at that spot, and so it's called an asymptote. And make sure to kind of start off here. So rational functions, we've talked about this before. Rational functions are definitely a fraction. They're going to have something on top, something in the numerator, and something in the denominator. So just kind of some visuals here of things that I think you should have in your head when you're thinking about asymptotes. So we're not going to actually go into stuff on this slide right now, but what I do want to think about on this slide is just this idea of what an asymptote is, and what are the steps defining asymptotes, and what are the different types of asymptotes. So I'll start off here with our definition. An asymptote is a line that approaches a function's graph more and more closely but never touches it. It's the limits of a graph. So maybe like when you were a kid, you think about how you pushed your parents' limits. Like your parents had a boundary and you tested them and pushed them and pushed them and pushed them to that line. Well, you were basically pushing them to their asymptote. You were getting them to that spot where they were upset with you, or they were going to punish you, whatever. And so it's kind of the same thing here. You're getting really, really, really close to it, but you're never going to get there because you know that you'll get in trouble if you do. In this case, if you get there, your function will become undefined and it won't work for that moment. What is a vertical asymptote? So a vertical asymptote is one that goes straight up and down, and we have a procedure to find those, and we'll look at that in just a minute. And then we have horizontal and oblique asymptotes. So just for conversation purposes, we're going to focus solely on horizontal and vertical, but I'll leave oblique here in the explanation so you can kind of see. When you find the vertical asymptote, there's actually some algebra that needs to be done sometimes. Whereas when you're doing the the horizontal asymptote, we have two rules for the horizontal, and like I said, we'll approach these in just a moment, but this is a rough run through. So the first rule would be is that if you have a polynomial on top and a polynomial on the bottom, if the degree of the top is less than the degree of the bottom, then you have a horizontal asymptote. And that horizontal asymptote will be at y equals 0. If the degree of the top function was equal to the degree of the bottom function, then your horizontal asymptote is literally just your leading coefficient. So it's just a over b. And then last but not least, and we will not be covering this, but if your degree on top was greater than the degree on the bottom, then you actually would use long division, and you would divide them out, and then that would actually give you your vertical asymptote. I'm sorry, your oblique asymptote. Okay, so let's go take a look at what asymptotes look like, because that was just our introduction. That's kind of like the start off piece. So let's take a look at what asymptotes look like in a graph. Okay, so we take a look at this guy right here, and I asked you to identify all of these things from this graph. We don't know what the function is, but we can clearly see that when we look at this picture here, and we talk about the domain, we can clearly see that this function is going to continue out here like this forever. So this would be negative infinity out here, and this is positive infinity out here. So it's going to continue forever. So my domain is going to come from negative infinity. It's going to come across, come across, come across, come across. And then you can see here that this line is going to be going straight up. Eventually it's going to be going straight up. And it's getting closer and closer, but the thing is this right here is called a vertical asymptote. And this right here is called a horizontal asymptote. And that means that according to the definition, my graph here will never get close, will never touch that vertical asymptote. So that means since my vertical asymptote occurs at x equals -4, that means my domain will go from negative infinity to -4. It will jump. We'll use the union symbol. It'll jump -4, pick back up at -4, and keep on going to positive infinity. Because it basically, even though it jumps and lands down here, it then continues itself out to positive infinity. So remember this guy right here, let's just add that in. Remember, this is called the union. And it's a symbol that we can use to show that both of these, it's kind of like an or. So when you think of union, think of or. We do the range. So we take a look at this function once again. So this is negative infinity down here. We can clearly see that this line is going to continue down. But it's continuing closer and closer to my asymptote, but that doesn't matter. Because my asymptote will never touch it, but we will continue to go down and down and down. So my range will come from negative infinity. So it comes from negative infinity up, 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 up. And yeah, it's going to turn this corner, but it's still coming up, 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 up. But then it will never touch its horizontal asymptote. It'll never make it there. Well, since our horizontal asymptote is at y equals 2, see that right there? Y equals 2. So same thing, we're going to go up to 2, we're going to jump over 2, we're going to pick back up at 2, and we'll continue to infinity. So you can see right here it picks back up, so I pick back up at 2, and it cruises up, 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 and continues going to positive infinity. I'd like to talk about vertical asymptote next. And so when I look at this guy for the vertical asymptote, I mean, we've already identified the asymptotes, to be honest with you. But in this case here, really all we need to do is just come over and say, okay, well, the vertical asymptote ended up being at x equals -4, and the horizontal asymptote ends up being at y equals positive 2. In this case here, we're just going to cross that off. We're not going to talk about it or entertain the conversation. This does not have an oblique, but we're not going to entertain the conversation at this point. We're going to leave that off. All right, so that's identifying asymptotes from a graph. And let's take a look at another example just to make sure we got it down. So a little more complicated problem here, but definitely very doable. So let's start off, I think the easiest thing when you have the visual, let's identify our asymptotes. So we take a look right here. This guy would be called our horizontal asymptote. As we cruise along and look at him, he crosses right there. So my horizontal asymptote is y equals 2. Let's do our vertical asymptotes next. So I've got a vertical asymptote right here and a vertical asymptote right here. So this would be x equals -2 and x equals, sorry about that, let me clean that up a little bit, x equals positive 2. So now you can remember, now you can see why we talked about graphing vertical functions and horizontal functions, because we need to make sure we understand that a vertical function is going to be an x equals and a horizontal function is going to be a y equals, which is counterintuitive to most people, because you know it's like they think, well, x goes side to side and y goes up and down. That's counterintuitive, but remember, it's all based upon who it crosses. So this asymptote crosses the y-axis, therefore it's y equals. This asymptote right here, this vertical, crosses the x-axis, therefore it's called it's an x function, or excuse me, equation. All right, so let's identify our domain and range now that we have our asymptotes. So I'll go ahead and write these in. So x equals -2, and x equals positive 2, y equals positive 2. Remember, no oblique. So our domain and range, so our domain would go from -infinity. It would go to that first asymptote at -2. It would jump over that asymptote. So it picks back up at -2 because it's a momentary thing. I mean, it is literally only skipping -2. That's it. It goes to positive 2, jumps over positive 2, picks up at positive 2, and goes to infinity. So basically what was happening here is that we were like, run. Actually, let's use my highlighter. We were like, run, jump, run, jump, run, and that was our domain, because we did everything except for those restrictive lines known as our asymptote. All right, let's take a look at our range. You're welcome for the sound effects. So then our range would, same deal, start at -infinity, cruise up, jump over excuse me, -2. That's supposed to be -2 right now. Sorry about that, I just caught that. Jump over the -2, pick up at the -2, and cruise to infinity. So once again, cruises along, jumps over. We need to make a minor adjustment here because we can visually see something. Let me change that just real quick. Now, this is a special circumstance. I don't want you to freak out and be like, I don't get it. This graph comes up to -2. So it comes up because that's where my asymptote is. But then there's some other funny stuff happening right here. So you can see that the first place that it starts back up is at, sorry about that, is at -1. So that's a special circumstance. You know, just go with what your visual, what your eyes are telling you, okay? Don't freak out about that. And then last but not least, if someone did ask you to find the intercepts, and I just put this on here for conversation purposes, well, we do have some intercepts. We have an intercept at 0, -1. We have an intercept at -1.5, 0, and +1.5, 0. All right, but remember, our main theme today is we're talking about domain and range, horizontal asymptotes, and vertical asymptotes from a display, from a graphical display.